Welcome to Kraton Chemicals, and thank you for visiting our facility. We want to make sure your time here is safe and productive. At Kraton, we embrace a global dedication to the health and safety of our visitors, employees, customers, neighbors, and environment. This video presentation will help you understand Kraton's life-critical procedures and is intended for contractors and employees who may work in high-hazard areas. If you have any questions after viewing this video, please direct them to the Kraton representative coordinating your visit. Safe work permitting is required for all work performed in the plant that could create some form of hazard. The purpose of Safe Work Permit, or SWP, is to document the risks associated with performing work or tasks. The SWP identifies potential risk the operating area or surrounding area may have on all contractors and employees performing the work, identifies potential risk of the task itself and the tools or equipment being used, includes control measures for identified hazards, serves as a communication tool to ensure operators are aware of work taking place in their area, and grants approval to perform the work. It ties multiple high-hazard Kraton work programs into one permit, including hot work, opening process systems, work from height, confined space entry, control of hazardous energy, work on live equipment, and excavation. Typically, Kraton employees or management will prepare the permit for the contractors to review. For high-hazard work, additional permits may be required to accompany the SWP. A method statement is required from Kraton and/or contractors, and a Tier 2 authorized signature on the SWP. Let's take a moment to review the Safe Work Permit form. Page 1 outlines instructions and definitions used to complete the SWP. Page 2 is used to detail the work to be performed and identify risk assessment, including hazard and existing controls. Page 3 is information only, nothing to complete. It relates high-hazard definitions, systems, and exemptions. Next, we address opening hazardous system, also called OHS or line breaking. This is the site of OHS permit, so no associated permit is required. The next section addresses lockout, tagout, or zero-energy state requirements, followed by sections used to determine if other permits may be required. The maximum duration of any SWP is 12 hours, and the entire permit must be reissued if work needs to be extended. Reissuance of a permit cannot be completed on the existing SWP, even if the job scope and risk is unchanged. Extension on SWP cannot exceed 24 hours. If the scope of work changes during the course of the project, the work must stop and conditions of the permit reviewed to ensure they are still appropriate. Some examples of changes include: the job is bigger than originally thought, the personnel changes, such as shift change, local conditions changes, such as weather, neighboring operations. When changes occur, reissue a new permit with the new conditions for major changes. Minor changes may be approved by the permit issuer. When closing the SWP, the contractor shall notify the operator that the work has been completed. This shall be documented on the SWP by the person performing the work and the preparer signing off on the SWP that is returned to HSES. In addition to the SWP, for high-hazard work, maintenance and contractors must complete a method statement. What is the method statement? It is a document that describes how the work is to be performed, identifies the work activities assessed as having safety risks, describes the control measures that will be applied, and includes a description of the equipment that will be used. Method statements are required for high-hazard work. Maintenance and contractors are the groups that are required to complete a method statement. Some routine tasks can have method statements that can be reused or typed for future work. Blank forms are available for completion prior to completing the work and can be saved for future projects. Here's an example of a method statement form. Control of hazardous energy is often called lockout, tagout, or zero-energy state, ZES for short. In order to control hazardous energy, all energy sources for a particular process, system, or piece of equipment must be isolated and the chance of unwanted or unexpected activation eliminated. There are 6 primary types of energy: electrical, mechanical, chemical, thermal, hydraulic, and pneumatic. Before performing a lockout-tagout, know the hazards of the equipment and systems, including the chemical and equipment hazards being locked out, equipment location, and the isolations points noted on SWP or ZES form, if they are greater than 3. Items needed for a proper lockout include your ZES form, color field locks, lockbox, chains, blank flanges, isolation tags and seals, valve covers, and plug buckets. The ZES form is created by a Kraton operator using our ZES generator program. This form will describe all of the critical sources of energy that needed to be locked out when multiple projects are underway. Colored locks are used. The color of the lock must be noted on the ZES form. Other items to note on the form are energy source, isolation ID, location of equipment, and verification of isolation activity to take. Lockout/tagout equipment consists of the ZES generator created form, board locks and forms which are colored locks, hasp for lock and keys, and the SWP and ZES forms that will need to be posted. Lockout/tagout or ZES include the following steps. First, a Kraton operator places a personal lock on the hasp. Locate the equipment to work on. Place the colored locks on the equipment. Isolate and verify equipment, and then initial the ZES form. Then notify maintenance the ZES initiation is complete. Maintenance will then place their personal lock on the hasp. Verify that ZES is complete and initial the ZES form. Notifies contractors that they can apply their personal locks to the hasp. The contractors will apply their personal lock to hasp. Work is then performed by maintenance and contractors. When the work is completed and the area is cleaned up, the contractor notifies maintenance and/or operations and removes their personal lock. Following the contractors removing their locks, maintenance removes their personal lock from hasp and will notify operations. Operations will remove colored locks from the equipment and place them back on the board. Initial the ZES form and removes their personal lock from the hasp. Once the work is complete, the ZES form will accompany the SWP to be turned into HSES once all work is completed on the SWP. Contractors need to be aware of the site lockout/tagout process and ask questions about unfamiliar equipment to ensure all energy has been verified to be isolated. A confined space is defined as one that is large enough to enter and perform work, but is limited in the way of entry or exit and is not designed for continuous occupancy. A permit is required in some confined spaces in which there is actual or potential hazardous atmosphere. Materials could engulf the entrant. The internal shape could trap the entrant. Or the space contains other serious hazards. These might include physical or mechanical hazards, such as moving parts, gases, liquids, fluids, heat or excessive noise, oxygen deficiency, combustibility, toxic air contaminants, or engulfed hazards. When working in these types of spaces, it's critical to understand the potential behavioral effects that may occur, including asphyxiation, too much oxygen that may cause coughing, fainting, or rapid breathing, and signs of fatigue including tiredness, weakness, irritability, indecisiveness, trouble communicating, and the inability to recall details. When completing the required permit to work in confined spaces, you will designate the space to be entered, purpose of entry, date and authorized duration of permit, authorized entrance, attendant names, hazards of the permit space, and measures used to isolate the permit space. On site, your authorized attendant can be a Kraton employee or contractor, and their responsibilities include review and sign the confined spaces entry permit, monitor entrance from outside the space, monitor and protect activities inside and outside the space, know the hazards that could be faced, understand behavioral effects of exposure, maintain an accurate count of entrants, communicate with entrants regularly, know how to summon rescue services, and perform non-entry rescues. Confined space entrants must also understand space hazards, review and sign the confined spaces entry permit, and know the equipment needed for safe entry. While in the confined space, the entrant must stay in contact with the attendant, alert the attendant to warning signs and symptoms, alert the attendant to condition changes in the confined space, and know how to respond in an emergency. In the event of an emergency, rescue and emergency services are performed by outside rescue services who have had extensive training. For non-entry rescues, entrants must use retrieval systems like a chest or full-body harness and a retrieval line. Work at height is defined as any work or access to work conducted on an elevated and unprotected work area, regardless of height, whether a person could fall a distance that could cause personal injury. This includes any work on mobile stairs and portable ladders, unprotected work on pipe racks, vessels, equipment, roof edges, and scaffolds, and work on elevating platforms. If you'll be performing any of the tasks defined as work at height, or when any personal fall arrest system or PFAS is donned, the work from height permit is required. Complete and sign the best plan for a safe outcome. Prior to the project, at minimum, the following must be performed. The area below work at height must be controlled using barricade tape and signage to minimize exposure to the hazard of falling objects. Work at height cannot be carried out when the weather conditions could jeopardize the safety and health of employees. A fall protection system is required for each worker on a walking or working surface with an unprotected side or edge, presents a fall hazard, or is 4 feet or 1.2 meters or more above another level. If a fall arrest rescue is needed, the fire department will be contacted. Line breaking is the intentional opening of a normally closed process system such as a pipe, line, duct, vessel, or equipment to the atmosphere. It is performed by unbolting or separating flanges, removing valves, opening pump covers, or removing instruments or gauges. In some instances, opening process systems involve highly hazardous materials and systems including toxic, corrosive, inflammable materials, such as systems containing boron trifluoride, phenol, solvent blends like xylenes and naphtha, alpha-pinene, and acetic acid, any hot process liquid with a temperature above 50 degrees Celsius or 122 degrees Fahrenheit, and high-pressure systems greater than 140 psi. Before opening a process system, it is imperative to prep the job site. Ensure that others passing through the work area will not be exposed to potential hazards and injury. Personnel opening any process system must wear the PPE listed in the line break section of the SWP. Block off the job site with warning signs, barricades, barricade tape, and caution tags, and allow only people involved in the job inside the barricaded area. For system preparation, all lines, vessels, and equipment should be cooled to the safest working conditions based on material properties, then verified, the temperature recorded on the SWP. Personnel must wear PPE that provides protection against the highest operating temperature present. If the system contains flammable liquids or gases, or is connected to a system that contains materials operating at or above its flash point, the following requirements apply. If the work area is left unattended or the work is stopped or suspended, the openings must be closed. The area within a 10-foot radius of the worksite must be free of open ignition sources, including open flames, hot work, or combustion engines. In addition to ZES requirements for lock, tag, and try, a direct reading detector must be used to verify the integrity of the isolation. You'll find the checklist related to opening hazardous system on the SWP. Energized electrical work is rarely used at our site. The Pensacola site uses contracted qualified electricians to perform high-hazard electrical work. Every contractor performing energized electrical work shall be a qualified person. Energized electrical work carries various levels of risk depending on the task. The following chart showcases risk by activity, beginning with lower risk to high risk, where exposure to 600 volts or greater constitutes high-hazard work. PPE requirements are aligned with the task and risk analysis at hand, ranging from natural cotton clothing, hard hat, safety glasses, hearing protection and leather gloves to arc-rated clothing, a protective hood with face shield, and hearing protection. Here's an example of an energized electrical work permit. When possible, do not work on energized equipment. Working under an immediate energy state or IES is preferred. IES indicates that hazardous energy sources have been eliminated while maintaining non-hazardous energy to perform the required tasks. It is acceptable to use IES when the work is by nature minor, routine, repetitive, and integral to the process. The equipment must be energized to perform work. The removal of a guard or safety device is not required, and a person's body part is not placed in a zone of danger. To work under an IES state, the simple one-page IES permit must be completed. Before performing any groundbreaking or excavation work, the groundbreaking permit must be completed. Contractors must designate a competent person for the work, which is typically a Kraton manager. Proper warning signs, barricades, and excavation protective systems must be erected before beginning work. Additionally, The location of utility and electrical lines, both overhead and underground, must be considered. If the excavation is deeper than 4 feet, an assessment of atmosphere is required, as is the completion of a confined space permit. Depending on the task, other work permits may be required. Hot work is any activity which has the potential to provide an uncontrolled source of ignition and can cause fire or explosion in certain conditions, such as in the presence of combustible, flammable, or explosive substances, or the presence of air. There are 2 classes of hot work based on severity of the perceived hazard. The first is low-hazard hot work, no flame. It includes generation of heat by friction like drilling and sanding, or activities that generate a low risk for sparks like using hand tools. The second is high-hazard hot work, which is work that generates a naked flame, such as burning or welding, or an activity with high risk of generating sparks, like grinding. Hot work requires specific personal protective equipment or PPE. First is for hand protection and consists of cut-resistant gloves, welding gloves, hand shields, leather gloves, or chemical-resistant gloves. All serve different protection for the various hazards that exist and must meet specific ANSI standards for gloves. Second, protective clothing must be worn. Welders should don flame-retardant clothing. Body parts that may be exposed to rays, slag, splatter, or molten material must be covered. Other protective including may include sleeves, jackets, bibs, aprons, and chaps. For eye and face protection and head protection, a welder's eyes and face must be protected against exposure to UV radiation, hot metal, sparks, and flying objects. A welding helmet, welding beanie, face shield, safety glasses, and/or safety goggles may all be required throughout the day in order to protect a welder's eyes. Eye and face protection as well as head protection must comply with applicable ANSI standards. Anyone assisting with welding activities or any visitors must don the same PPE as the welder and are prohibited from looking directly into a welding flame. Looking directly into a welding flame can cause permanent eye damage. When performing hot work, ensure that slags are contained. Slag is a non-metallic byproduct of certain types of welding processes. When performing hot work, ensure that welding slag is contained and that no combustible materials, flammable liquids, cylinders, or debris can come in contact with it. Additionally, atmosphere testing is required when doing hot work. Tests must be taken at different locations by a Kraton employee around the work area to ensure that there are no pockets or layers of flammable materials. Continuous atmosphere testing is mandatory for high-hazard hot work in high and medium hazard areas, or when working within 35 feet of other equipment that contains flammable materials. While performing the work, fire watch personnel must maintain surveillance of the areas where hot work is and has occurred. Welding and cutting both cause sparks and bits of molten metal to fly into the surrounding area. The fire watch maintains a lookout for small fires started by these sparks and bits of slag. The fire watch must also maintain conditions and requirements stated on the safety permit. Keep flammable materials from ignition sources. In the event of fire, extinguish it immediately or set the fire alarm. Call 911 or emergency alarm number. Stop operations if any hazardous condition is found. Performing hot work does require the completion of the hot work permit. The duration of the permit must not exceed max of a shift or 12 hours. Work which extends over many days requires a fresh permit at the start of each shift. An authorizer is to revisit the job site to confirm conditions are unchanged from the original permit authorization and include revitalization of isolations for hot work activity. Hot work permit may be closed under the following circumstances. The work is completed and the acceptor signs off on the job. The permit duration expires with work still outstanding. A significant change in permit conditions or an emergency occurs. The acceptor is found to be working outside the stated scope. Finally, upon closing the permit, the acceptor or fire watch personnel must check the area after work is completed to ensure no hidden sparks remain. Airborne clouds of combustible dust are easily ignited, resulting in the rapid, violent spread of fire, or deflagration. If confined inside a structure, the pressure can build up, creating an explosion. Deflagration or explosion can cause loss of life and property damage. Welding and other hot work operations initiate many workplace combustible dust explosions. Dust trails on surfaces can act as a fuse to serve as a source of ignition in other areas. Therefore, welders should understand the factors that contribute to combustible dust hazards. Always understand the materials that may be present in the environment and check when you are not sure. Never use compressed air for cleaning powdered materials and dust. Never weld or do hot work where combustible dusts are present on surfaces or where they might become airborne. Check adjacent and concealed spaces for dust. Never work on equipment that handles or collects combustible dust unless you're authorized to do so and have the required training. Always be careful about electrical safety, including static charge buildup. Always follow all safety precautions, hot work procedures, and other steps designed to prevent dust explosions. Kraton is dedicated to providing a safe and healthy workplace for both employees and all who visit. Therefore, 8 life-critical procedures have been identified as considerably hazardous. We trust you are committed to the same and will work with us in advancing this goal. If you have any questions, please discuss with the Kraton representative who arranged your visit. Thank you for visiting and be safe.